Today, today I'm going to start the stability check of retaining wall. In the last class, in the previous class, we have discussed about the different types of retaining wall and the theory which is related to different types of retaining wall that we have discussed in the last class. Today we'll discuss about the stability check of retaining wall, because retaining wall should be designed properly so that uh, that can withstand the backfill soil for its design life. But as this is a simple structure, that's why we cannot, or we are not designing it as we do in the structural analysis classes, or we have designed building or steel structure, not like that. But we have to just check the stability after assuming the dimensions of the retaining wall. Now, first in the notes, I have presented a note already. I think you can see the presentation. If you face any problem, please tell me. Now, before going to the going to check the stability of the retaining wall. First of all, we have to assume some dimensions of the retaining wall, the required retaining wall for the retaining wall which is required for some site. Now, that assumption of the dimensions is called proportioning of retaining wall. Now, this proportioning, uh, we cannot assume any value coming to our mind, but there is some provision, some codal provision, uh, by which, or by abiding which, we can be allowed to assume the different dimensions of the retaining wall. And as these retaining walls are simple structure, we can only assume the dimensions. And finally, in the cantilever type of retaining wall, we can allow, or we can provide some of the steel bars. Those structural design is not very much important in the context of geotechnical engineering, but the stability, that means the retaining wall, whether the retaining wall can withstand the earth pressure coming from the backfill soil or not, that is the main topic to discuss. Okay. Now, coming to the proportioning of the retaining wall. Now, as I have told, that to assume the dimensions, assume means uh, before going to design the retaining wall or any structure, we have to assume. Let's take an example of some building. We have to assume the size of the beam, size of the column, thickness of the slab, like that. We have to assume here the different dimensions of the structure. Now, as per the provision, the top thickness of the retaining wall should be in between 0.3 meter to h by 12. Now, h is this one, total height of the retaining wall from surface to the top of the retaining wall, and this is gravity retaining wall, this is cantilever retaining wall, this is the height of the retaining wall. Now, in case of gravity retaining wall, the top thickness must be in between 0.3 meter to h by 12. If, obviously, the condition is if the height of the retaining wall is sorry, h by 12, the value of h by 12 is greater than 0.3. That means the height of the retaining wall, if the height of the retaining wall is greater than 4 meter, then only 0.3 to this h by 12, this value can be considered, but if the height is less than 4 meter, then only 0.3 value, 0.3 value minimum thickness of this top thickness is 0.3 meter should be considered. And in case of cantilever retaining wall, minimum wall thickness at the top must be 0.3 meter. Minimum value is 0.3 meter. Now this one is h, the slab thickness, this one is d, this slab thickness, uh, foot slab thickness, this one is d. The provision for the value of d is h by 8 to h by 6, that means 0.125 h to 0.17 h. H is the height of the retaining wall. In case of cantilever retaining wall, this is h by 12 to h by 10. H is obviously, first of all you have to assume h, not assume h, you have to consider h by visiting the site. That means how much amount of soil or how the backfill soil height is there in the site, you have to note that, and that should be the height of the retaining wall in both the cases. Okay, now the slab thickness is these to these, that means range is h by 12 to h by 10 for cantilever retaining wall, and h by 8 to h by 6 for gravity retaining wall. This one this one that means the extension towards toe, this one for gravity retaining wall should be d by 2 to d is this one, that means half of this thickness to full of this thickness, that must be the extension towards toe. Okay, and for cantilever retaining wall, this extension must be b by 3, minimum extension must be b by 3. Okay, now bottom thickness of the main wall, that means if we leave this slab portion, then this thickness uh, of the retaining wall, that is dependent on this batter angle means this angle with vertical, the inclination of the front surface of the wall uh, with the vertical plane, that is batter angle, and this batter angle is 1 by 48, that means tan theta equals to 1 by 48, and you have to calculate theta, that means angle you have to calculate. Okay, and anything else, that is, yes, that is in case of cantilever retaining wall, the batter angle is 1 by 48 or 1 is to 48, and this one, the bottom thickness of the retaining wall is 0.1 h, and mm, and yes, the width of the base slab for gravity retaining wall is 0.5 h to 0.7 h. Okay, 0.5 h to 0.7 h, and for cantilever retaining wall, the width of the base slab is 0.4 h to 0.7 h. So first of all, the primary dimension is h, that is the height of the total height of the retaining wall. From h you can calculate this slab thickness, this base slab width, uh, all those things. Okay, and from d, this front extension, and from b, this front extension in case of cantilever retaining wall can be calculated. Okay, this is called this provision, by avoiding the provision, the calculation of the dimension or assumption of the dimension of the retaining wall is called proportioning of the retaining wall. And another thing, another assumption or another proportioning for counterfort or the buttressed retaining wall, that is all other things are similar because we have discussed in the previous class that buttressed retaining wall or counterfort retaining wall is a special case, two special case of cantilever retaining wall. So all the other dimensions are taken according to this one, this cross sectional dimension, but the extra dimension is the gap between the counterfort or gap between the buttress retaining wall. In case of buttress retaining wall, these slabs are these triangular slabs are given at the front side, and in counterflow retaining wall these slabs are provided in the back side inside of the backfill soil. Okay, only the difference between the counterfort and buttress retaining wall is this, and one provision is there, that is the thickness of this slab, that is 0.2 meter minimum thickness of the slab uh, are 0.2 meter, and the gap between each two slab should be 0.3 h to 0.6 h, and h is the total height of the retaining wall. And in case of buttressed retaining wall, the proportion is similar, only the position of these triangular slabs are at the front side of the retaining wall. Now, okay, this one is the proportioning of the retaining wall. If you have any question, you can ask. Otherwise, I can proceed to the next topic. Have you any question regarding this up to this? Okay, if not, then I'm going to proceed to the next topic, that is the check for stability of retaining wall. Now, what we have to do for designing the retaining wall, that is, first of all we have to assume the dimension of the retaining wall on the basis of the height of the retaining wall that is required, and that height can be determined from the site visit, and the height of the backfill soil or required height of the backfill soil is the height of the retaining wall, and on the based on that value of h, other dimensions are computed, and obviously those are assumed because there are ranges, that is 0.4 h to 0.7 h, there is one range for the width of the base slab. That means we have to assume in between these two range. That means if the height of the retaining wall is 10 meter, that is required for this kind of backfill soil, then the base width for a cantilever retaining wall, base slab width should be 4 meter to 7 meter. But obviously you have to take a specific value, that means you may take it as 5 meter or 6 meter, or you may take this slab thickness as that is 10 meters, that means 10 divided by 12, uh, that means 0.8 meter to 1 meter. You may take 0.8 meter, you may take 0.9 meter, or you may take 1 meter also. That means which value is actually correct for this retaining wall with all the data given, all the soil data and all the material data, that may be the retaining wall is built up of concrete or PCC or RCC maybe, then all the property of this material and all the properties of soil is given, then you have to check if these assumption, these proportioning or this assumption of the dimension is right or wrong. That means I have, if I want to take the width of the base slab is 5 meter, and thickness of the base slab is maybe 0.9 meter, then this extension is 0.3 meter, this one is okay, 1 by 50 I can take. This one is 0.3 meter I can take, and this height is determined from the side, that is 10 meter. I have taken this one and I can design the retaining wall, but before place the retaining wall or before construct the retaining wall, we have to check whether these proportion or these dimensions are correct to withstand the pressure coming from the soil. And pressure coming from the soil means, the pressure means horizontal pressure, that means the earth pressure. The earth pressure coming from the backfill soil, these retaining wall must be retained, and that's why we have to go for the checking of stability of the retaining wall. So there are three kinds of failure. One is overturning failure, one is sliding failure, and last one is bearing capacity failure. And last of all, in some of the books you may get that overall failure means summation of all these three. Okay, overall failure of the retaining wall. But dividing that overall failure, these kinds of three failures are actually the part of the overall failure. One is overturning failure, one is sliding failure, and one is bearing capacity failure. We have to check if our assumed data or assumed dimensions are right or wrong by checking this. Now coming to these 3 points, that is overturning means, if you can see this figure or this figure, overturning means that word about toe. This is very much important. Overturning means if pressure, earth pressure, horizontal earth pressure is coming from this way, that means total load is actually this way, and yeah, the retaining wall is tends to overturn by this, by rotating. Top portion will rotate and overturn like this. Tends to rotate, not rotating, but tends to rotate by this way, and that rotation is about this point. This point is called toe. Okay, this kind of failure is called overturning failure. So we have to check if the retaining wall is resistant enough to prevent this overturning failure. Next one is sliding along the base. Sliding means nothing but the horizontal displacement. The retaining wall is not overturned or not rotated, but sliding means horizontal movement. That means retaining wall is actually moved in a straight way. That means slide over the soil, over the soil surface. Okay, slide, and this base slab is actually sliding. That's why total retaining wall is sliding or moving through this way, or this retaining wall may also slide through this way. Okay, and third one is check for bearing capacity failure. The third failure is bearing capacity failure. And bearing capacity failure, I think you have studied about bearing capacity in shallow foundation chapter. And bearing capacity failure means this retaining wall is actually settled down. This soil cannot take the load of the bearing capacity, sorry, cannot take the weight and the load coming from the soil and this retaining wall. That's why this retaining wall is actually settled down, and the soil is actually settled down due to this load coming from the retaining wall. That is called bearing capacity failure. Now these three failure are not desirable, and we have to prevent this by making the retaining walls much stout or enough stout by assuming the proper dimensions. That's why you have to check the stability. Now coming to the uh, overturning failure. Now, overturning failure, if we want that the retaining wall is not retaining wall does not overturn due to the load, due to the earth pressure or the pressure coming from the soil, then this formula of factor of safety, FOS means factor of safety. Factor of safety value must be greater than or equal to 2. That means there is a safety factor we are considering, but the moment, actually rotation, as I have discussed, that due to this load, this retaining wall tends to rotate this way, and this overturning is occurred due to the moment, because this is not a straight force. This is this kind of movement, this kinds of rotation can be occurred only due to the uh, moment. That's why here in the factor of safety I have just take the sum of the resisting moment divided by the sum of the overturning moment. That means you have to add all those moments which are the cause of the overturning, and you have to add all the moments value which are actually resist the overturning phenomenon. Okay, now as I have discussed that this by this way this wall is actually overturning. That means resisting moments are working this way opposite to the overturning moments. Okay, that means these kinds of moments, this is the direction of clock. These kinds of clockwise movements, in this case obviously when this side is backfill soil is in this side, then these clockwise movements are resisting moments, and anti-clockwise movements are overturning moments. This is anti-clockwise direction. These are actually the region of the overturning phenomenon, and the clockwise movement in this case is the resisting moment. Okay, now for all the checks, I have taken one simple example of cantilever retaining wall. We can take an example of gravity retaining wall also, but in your syllabus only cantilever retaining wall is there. That's why I have taken a simple retaining wall, that may be gravity retaining wall, maybe cantilever retaining wall, and the total height of the retaining wall I'll go to these other checks also with these same examples. That's why I have describing the example at the primary stage of the checking. Okay, now please listen carefully, because I cannot write in the blackboard, or I cannot show you the calculations by this time, but I can give you one simple problem by which you can understand the process to process for all the checking. But for now I cannot write or cannot calculate all the things, but I can only describe, only explain the way, explain the process of checking. Okay, now here I have taken one simple cantilever retaining wall. That overall height of the retaining wall is 6 meter. uh, the embedded depth is 1 meter, and the uh, uh, depth of the retaining wall above the soil surface is 5 meter. So total depth of the retaining wall is 6 meter. uh, Minimum top thickness is 0.3 meter, as we have already discussed. Here the top thickness is taken 0.5 meter. The inclination angle of the soil surface of, or the backfill soil surface precisely, that is 10 degree. The soil property gamma and phi is given. From the property, this is easy to comprehend that the soil is cohesion less soil or the sandy soil. Sand is written there, that means cohesion less soil, as there is no value of C. Maybe in your exam, or maybe if you want to solve any problem, maybe this sand is not given there, but this kind of properties, this kinds of value is given there. And if C is not given, then that is cohesion less soil, obviously you have to assume. The thickness of the base slab is 0.5 meter. There are three parts in the base slab. Total width of the base slab is 2 to 3.5 meter, and three parts are divided. Front extension 1.5 meter, back extension towards hill, that is 1 meter, and the bottom thickness of the retaining wall is 1 meter, this one. Okay, that uh, all the data are given like this. Okay, now first of all, as I am discussing about the overturning, checking for the overturning failure, first of all you have to determine, please listen carefully, you can write it also. I'll give you the notes, but you can write it also, the steps. I can give you the notes with the solution of this problem, but the steps you have to remember in your exams. First of all, you have to calculate the active earth pressure, and you know the equation of the active earth pressure, that is half multiplied by uh, Ka gamma H, sorry, Ka gamma H is the active earth pressure, sorry, active thrust or active load, that is half of Pa multiplied by H, that we have already discussed in the previous classes. So first of all, you have to calculate the total active thrust or total active load that is coming from this way. And as there is an inclination in the backfill soil surface, obviously we can assume the pressure, active earth pressure and active thrust is acting in this way, inclined uh, by 10 degree with surface, sorry, with horizontal surface, by this way. Okay, now another thing you have to calculate, that is PP, that means passive thrust, that is coming from this way, from this way, for this soil, for this embedded part only, because as the overturning criteria is like this, that means retaining wall is actually moving towards this, that means for this part of soil, retaining wall is coming towards soil. For this part of soil, this part only, this embedded part, the wall is moving towards the soil, and for this backfill soil, the wall is moving away from the soil. So for this soil, we have to calculate active pressure and active thrust, and for this soil, we have to calculate passive pressure and passive thrust. Okay, now as this active thrust is acting inclined way, so we have to divide this inclined force or inclined active thrust into two components. One is horizontal component, that is P. If the active thrust is PH, active thrust is PA, sorry, active thrust is PA, then horizontal component will be PA cos 10 degree, and vertical component of this active thrust is PA sin 10 degree. By that you can calculate the two components, one is horizontal components, one is vertical component. This PP, this surface is horizontal, that's why total passive thrust is acting horizontally, there is no component, no vertical component here. Now we have to divide these retaining wall by our convenience so that we can calculate the weight of each part of the retaining wall, as well as the same thing we have to do for the soil part also. Now, how much soil we can take for integrated part of the retaining wall? How much soil? That is this much soil we have to take, the part of the soil which is actually standing on this slab extension. This part of soil we have to take as the integrated part of this retaining wall. And and the weight of these retaining wall and this part of soil. To calculate precisely, or for the sake of the advantage of calculation, we can divide the retaining wall and this part of the soil into different parts, into simple geometrical shapes. Like, this is one trapezoidal shape, and if you want to calculate the weight of this part of retaining wall, weight you can calculate easily for with some uh, definite equations of trapezium. But after that you have to calculate the moment. In that case of calculation the moments, you will face some problem. That's why for this trapezoidal section you can divide it one rectangle, and one triangle, because we know the CG of the triangle and the CG of the rectangle, where the CG is there in the triangle and where the CG is there in the rectangle, we know. That's why we can divide this trapezoidal section of the retaining wall into two parts. One is triangle, one is rectangle. This part is rectangle, very simple or basic shape. Now for the soil, this part of soil, this is also one trapezoidal section. That's why we can divide it into two parts. One is rectangle part and top triangle part for this one. Okay. Now, how can you calculate the weights of all these? For calculating the weights, first of all you have to calculate the volume of each part. Volume can be calculated by multiplying area with the length means that dimension which is actually perpendicular to the screen. That means this way. That means in the previous figure, this length, this is the length. That means if the area of this cross section is A, then you have to multiply this A with L. A multiplied by L, that is the volume of the retaining wall, and volume multiplied by unit weight of the material. There are two types of material. One is retaining wall, that may be constructed with concrete, PCC or RCC maybe, and one is soil, and the unit weight of the soil is given. That means the area multiplied by length of the retaining wall multiplied by the unit weight of the retaining wall. Sorry, this is the unit weight of the retaining wall, and the area of soil multiplied by the length and multiplied by the unit weight of the soil. That is the total weight of this part retaining wall plus the soil, integrated part of soil. Now, as we can assume L is unit, that means we are considering unit length of the retaining wall. This unit weight of the retaining wall, for the sake of the easiness of the calculation, then all the term of L will be eliminated, and only the area multiplied by unit weight, that will be the weight of this part of the retaining wall. Now After calculating all the parts, as we have divided the retaining walls into different parts and the soil into different parts, so we have to calculate all the areas, volumes and weight for the different parts, and the easy way to do this is to make a table like this. In this table several columns should be there, maybe serial number, area, weight or load, and lever arm factor, because from weight or load you have to calculate the moment by multiplying the weight or load with lever arm factor. Lever arm factor means nothing but the distance of the CG of that area from some specific point. Okay, now there may be several rows, how much parts are there, on that the number of rows are dependent. Let's do it, do the table, make prepare the table. Okay, weight or load, lever arm from toe, because in the definition of the failure I have told that overturn can be occurred about the toe. That means this point, if the point is O, then you have to calculate all the distance from the CG of the different parts from this point. Okay, lever arm distance from toe, and finally, oh sorry, one I have left, this one is lever arm from toe, and here weight or load, and in the second column there must be area. From the area you have to calculate weight, or weight of the retaining wall and weight of the parts of the soil, and finally you have to calculate moment by multiplying this one and this one. Okay, now if we want we can divide this retaining wall into one part, two part, one rectangle with width 0.5 meter, one triangle with base 0.5, because if the top thickness of the retaining wall is 0.5 and bottom thickness of the retaining wall is 1 meter, that is given, then triangle, base of the triangle would be 0.5 and the width of the rectangle would be 0.5. The base slab, that is having thickness 0.5 and base width is 3.5 meter. Okay, there is one part of soil, rectangular soil part, the width of this one is 1 meter and height is 5 meter. One triangular part, you have to calculate the base of the triangle, and sorry, base of the, not base of the triangle, base of the triangle is 1 meter, and height of the triangle you have to calculate with this 10-degree angle. Okay, so uh, if you want to number this 1 2 3 4 5, okay, in the notes I will uh, number all the parts and will give you the total picture. Okay, now if we want to calculate for this part, this rectangular section, that is 0.5 multiplied by 5 meter, 0.5, sorry, not 5 meter, but this one is 0.5 meter, means 5.5 meter. 5.5 is the height of the rectangle and thickness of the rectangle or width of the rectangle is 0.5 meter. That means area should be 5.5 multiplied by 0.5 is equals to how much? Can anyone say? I think this one, 27.5 meter square. Okay, now if we consider the length of the retaining wall, that dimension is perpendicular to the screen, the length of the retaining wall is 1 and then the volume of this part is only 27.5 meter square multiplied by the unit weight of the material of the retaining wall. Now if this is cantilever retaining wall, then we can assume that the retaining wall is made of RCC, reinforced cement concrete. Then the unit weight of reinforced cement concrete may be considered as 25 kilonewton per meter cube. 25, sorry, 25 newton per meter cube. Then 27.5 multiplied by 25, this is the total weight of this part. Gamma H equals to, here Ka, you can calculate Ka by the formula, that is 1 minus sin phi divided by 1 plus sin phi. The value you can calculate 1 minus sin 36 degree divided by 1 plus sin 36 degree, that is approximately 0.26. Okay, that means PA is 0.26 multiplied by gamma, that is given 18.5. This is I am calculating for soil, and H is here, total height is 6. So the value of active pressure is 0.26 multiplied by 18.5 multiplied by 6, that is 28.86. maybe you can calculate kilonewton per meter square. Okay, now coming to the active thrust, that is capital PA equals to half of 28.86, that is the value of active pressure, multiplied by H, that is 6. 6 multiplied by 0.5, that is equals to 86.58 kilo Newton per meter length of the retaining wall. So for this, and this active thrust is acting inclined to the surface of the retaining wall at an angle of 10 degree. That means the horizontal angle, that may be denoted as ph, equals to 86.58 into sine 10 degree, equals to 15.03 kilonewton. That means in the serial number 5 maybe the value of pH you have to take. pH equals to 15 point how much, 15.03, 15.03, sorry, not in this but in this, because this is one load, or this is one load, that's why this much of kilonewton. Lever arm, that is this one is acting like this at this surface. At this surface, this one is acting horizontally. That means lever arm will be this vertical distance, this is acting this way. Weights are acting vertically, that's why the lever arm is calculated horizontally. But in case of the active thrust, the thrust is acting horizontally, that's why lever arm is we have to calculate the lever arm vertically, and the active thrust is acting at one third from the one third of the height of the retaining wall. That means total height is 6. So lever arm is from this to 2 meter height. That means here the lever arm is 2, the moment is here 30.06. This is the calculation of the all the moments, and finally you have to decide which moments are the reason of the overturning phenomenon and which moments are the resisting moment to the overturning failure. Okay, and finally you have to add all the moments which are resisting the overturning process, and add all the moments which are actually the reason of the overturning moments. Now as we have here two values, that is one is the height, sorry, weight of the one of the part of the retaining wall, this is the resisting moment, this is one of the resisting moment. That means this will come at the at here, that means resisting in the place of resisting moment. Okay, but the horizontal component of the active thrust will act as the overturning moment this way, anti-clockwise moment in this case, and this moment will act clockwise moment. That's why these two examples I have given, this one will be resisting, this one will be overturning moment, and by this you have to calculate this factor of safety. And if the factor of safety is greater than 2 or equals to 2, then our assumption is correct, assumptions is okay, we can certify it as uh, okay. But if the factor of safety is less than 2, then the assumptions or the proportioning of the retaining wall must be changed to other dimensions. Okay, okay, I think time is up. In the next class, I will go for the other two failure criteria, how the factor of safeties are calculated for those criterias. uh, so